What happens if you try and check if two objects are the same? You can't, so let's build a custom function to achieve that. Hi, my name is Abba, and today we're going to walk through how to override the equals function to compare objects. So in this example, we have a class person with a string name, getter and setter, int age, getter and setter, a constructor to initialize the values, and a public override on the toString just so we can print them out to the screen. If you don't understand the usages function, I have a video specified above that you can watch it and understand. And then in the main, we just have two people defined. We have a person Abba, Abba25, and a person John, John25. So let's try and print these out to the screen just for starters. We can say Abba, Control D, and then print out John. And because of our override on the toString, we actually gain these values denoted here. And we can have a \n to put it on a new line, or we can do something like \t to use the tab operator. There we go. So now that we've got them both printed to the screen, we want to be able to compare if this person is equal to this person. So let's see what we can even do here. If we go console write line, Abba equals John, let's see what happens when this runs. The value just says false. Now if we make them exactly the same, let's see what happens. Abba25, Abba25. And you can see that the value is still false even though all the variables are exactly the same. This is because when you compare an object, they don't actually compare the values, they just compare the reference to the memory. Now that's not exactly what we're trying to achieve. We don't care about the reference to value, we actually just care about the variables inside. If these two are exactly the same, then they are the same person by definition. But of course this is a custom definition because we've made our class, and C#, the compiler, doesn't know anything about our custom class and what properties it does indeed have. Person can have 10 different properties, but we can differentiate and say that if these two properties are exactly the same, then they are the same person. So let's see how we can make this happen. So we do have an equals function available, and we'll test it like this. We can say abba.equals, and then Abba equals out to John. Now if we run the code, we should see the same output. Again, it's false. So let's build our custom function. So just like we have here, we have a public override on a string and a toString. So let's say public override, and we want to override the equals, and as you can see, it's actually available here for us. Perfect. So this returns back a bool because the equals is just a simple true or false. If they're the same, we return true. If they're not the same, then we return false. And then by default, it accepts an object. What you can do at this point and say, do you want everything to be accepted by this, or do you only want a person to be accepted? Now, the problem with the equals function is it actually doesn't let you specify just the person, because the equals function takes in an object. So we have to make it generic, and then inside our code, we can actually make it specific. We use these operators called is and as to be able to check it and also cast it at the same time. So let's explain how this actually works. So let's start writing some code. Our first step is to check if the object that's passed in is going to be of type person. If it's not of type person, then we can't compare it. Because this object means that we can pass in a name, we can pass in a string, an integer, you can pass in everything because everything is an object. As it says here, it supports all the classes in the .NET framework. So anything can be passed into this function. So for example, you can say Abba equals 10. Now logically this doesn't make sense because 10 is an integer value and Abba is a person. But because this accepts an object, we can literally put anything we want in here, including strings. So let's revert this back. And then in order to be able to write this code, we first need to check if the value that's passed in is of type person. So using this getType function, we can actually demonstrate this exactly. So let's do cw tab and we can say obj.getType. And then because this wants us to return a boolean, otherwise it won't compile, for now let's just say return false. And let's see what happens when we execute this now. You can see it says equals person. This equals is because it comes from our namespace called equals, and then .person is going to be our class person. So what that's saying is the value that we're passing in, which is John right here, is of type person. So now let's run with 10 and see what happens. As you can see there, it says system int 32, and let's do the same thing with a string, and it says system.string. So that's what we're going to use to differentiate between a different value and our person class. So we can put John back in here, and we scroll back up to the function, and instead of using this, what we can do is we can say something like this. We can say object is person. And now let's run this and see what happens. So we run that code, you can see it says true right there, because it's determined if it is a person. And this is a pretty simple statement. It just checks if this type is of type person. Now if we put in 10 down here, we should see 3 falses come up on the screen. Exactly, because now it's determined that that is not actually a person that's being passed in. So this is our first step. So we can say if object is person. Now at this point in this code, we know that object is a person. And now we've confirmed that, so anything that we do down here can assume that object is going to be a person. So then what we can do is we can initialize a new value by just assigning it in. So we can say person equals object. Now this doesn't make sense because an object can't be placed into a person because an object is going to be generic. This is where the as keyword comes in. So we can say object as person. And this is pretty safe doing it down here because we've validated that object is a person, so then we can make it as a person. If you try to do this line up here and the value passed in is not actually of type person, then you're going to have an issue. Let's demonstrate that. So we can just say person test object as person. Now if you run this code, we shouldn't have any issues right now, but there's going to be an issue when we actually type in 10. You see, it returns back false. Now if we try and print this, we're going to get an empty space because this is indeed not a person, because at this point it's actually passing in an integer. So now if we type in John down here and run again, see that the values of John comes up. Now of course our John is actually called Abba, so let's revert that back. Let's run it again. So John gets passed in and then we cast it over to a person and then we can access the values directly. Perfect. So now that we've done that step, let's have a look at what's next. So we've checked it's a person, and then now we make the object, and then this is where we return the values. So now we can use our person to compare. So as we said before, if the names match and the ages match, then we can validate that they're exactly the same. So we can say name equals person dot name and age equals person dot age. And it's actually that simple. This name is coming from this public string name, and the age is also coming from here, and they're being used within here. So if we've determined it's a person, we cast the person as a person, and then return if the name equals the name and the age equals the age. And if this check fails, the object is not a person, then we want to return false because it'll never be the same if we're not going to be comparing a person class. So let's remove this console write line and then let's give it a shot again. Let's hit F5. Now you can see they both say false because Abba and John are now different. Now if we make this Abba again, and there you go, it's actually returning back true. So as you can see, this notation won't work because we're overriding the equals function. So let's comment this line out and let's run it again. And you can see we have true and it's all working now. This is the equivalent of doing something like this. Abba.name equals John.name and Abba.age equals John.age. And I'm fairly sure that when you run these two lines, it's actually going to return back true, because we're manually converting this rather than doing it through the class. Now the problem with this is just because we're doing it down here and not inside the class, it means that every single time we want to compare, we don't have it in a function and it's going to make our code really ugly. It's really easy to read this, does Abba equal to John? Now in this case, we only have 2 fields to compare, but let's say this field is 4 or 5 in length, then this is going to get pretty lengthy at how expensive it's going to be to write every single part individually, or we can just add it in once up here. And that's the benefit of overriding the equals function for our custom classes. The reason why this doesn't work out of the box is because the compiler doesn't know about any of the properties that we've specified, so we have to make a custom function to tell it, if this equals this, then return this value. This can be really powerful in big systems where you're comparing 2 different classes that are exactly the same, like if you're loading data from 2 different locations and you're checking if they're the same before doing a certain operation. Using custom classes like this helps a lot to be able to tidy up your code and make it more readable for the future, and you don't have code like this lying around, you just have it wrapped up inside the class and it's all in one central location, which helps to keep your code maintainable and easy to add in future developments. Thanks for watching. If you have any questions, drop them down below and I'll see you in the next one. This video was made possible by my awesome Patreons DP Unique, Tominator, BuddyWoody9 and Rohan. Thank you for your continued support. I have a C# Masterclass Udemy course coming up soon. Make sure you're subscribed to the channel and join the Discord server for exclusive discounts and promotions.